Hi everyone, this is Mrs. J, and today we're going to be modeling quadratic functions. So I have a quick warm-up for you guys, so please pause the video and give these a try, and then hit play when you're ready to check. Alright, go ahead and check your work. So the first problem is in standard form, so you need to use negative b over 2a to find the x value of your vertex, which is 2, and then substitute it to find the y value, which is negative 7. For part B, this is in intercept form or factored form. So from this, we can tell that the zeros occur at negative 6 and positive 4, and the x value of your vertex is always going to be exactly in between them. So the exact middle of negative 6 and 4 is at negative 1. And then all you need to do is find out what f of negative 1 is, and you should get a y value of 50. And equation 3 should be the easiest one because it's in vertex form. So we can see just by looking at it that the vertex is positive 5, 3. Just remember it's always opposite of whatever you see grouped with x. So today we're going to be working with real-life examples that can be modeled using a quadratic function. So let's look at example 1 together. This says a gardener has 140 feet of fencing to put around a rectangular vegetable garden. The function a of w equals 70w minus w squared gives the garden's area, which is a, in square feet for any width, which is w. Does the gardener have enough fencing for the area of the garden to be 1,300 square feet? So again, in this quadratic function, the input is the width of our garden, and then the output would be the area of the garden. So this function allows us to test any width we want to figure out what the area would be. Or we could try a given area and figure out what the width would be. So since they say that the garden would have an area of 1,300 square feet, that should be the output. So we're going to replace a of w with 1,300 and see if this is possible. So essentially what they're asking us to do is to solve for w. And if we can find an answer that makes sense, then it is possible. And if we can't find an answer, then it is not possible. And do keep in mind that since w is the width of a rectangular garden, w does need to be positive because it wouldn't make sense to have a negative width. So let's see if we can solve this equation. It is quadratic, so let's try setting it equal to 0. And we would like the w squared term to be positive. So let's actually add it to the other side. So we're going to add w squared to both sides to make it positive. And then we will still need to move this to the left side of the equation as well. So we'll subtract 70w at the same time. And this gives us w squared minus 70w plus 1,300 equals 0. So here there's a lot of different ways we could try to solve. I'm going to go straight for the quadratic formula because I know it will always work. So again, we're going to be using x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can see from our equation that a is 1, b is negative 70, and c is 1,300. So let's substitute those values. So x equals negative 70 plus or minus the square root of negative 70 squared minus 4 times 1 times 1,300 all over 2 times 1. So if we start simplifying this, we get positive 70 here plus or minus the square root of. So be careful, this becomes positive because we're squaring a negative number. So it becomes positive 4,900. And then this will stay negative because of this negative. And this becomes 5,200 all divided by 2. And then if we take one more step here, we get plus or minus the square root of negative 300. So here, hopefully we remember that we can't take the square root of a negative number. So this actually means that there's no real solution for this equation. So if we go back and look at the question, it says, does the gardener have enough fencing for the area to be 1,300 feet? Well, when we plugged in 1,300, we got no solution. So I'll write no solution here. And again, it's because we cannot take the square root of a negative number. So the answer to the question is no, the gardener does not have enough fencing. So we would say no, not enough fencing. So next we're going to try a couple problems that involve projectile motion. So below we have two really commonly used quadratic models that help us work with objects that are falling near Earth's surface. So this first model tells us how far something has fallen after a certain amount of time. And this second model tells us the height of something falling after a certain amount of time. So I want to draw a little picture to visualize each of these because they're kind of similar. So this first model again, imagine that where something is falling from the top of a building like this. So this model, d of t equals 16t squared, tells us the distance something has fallen in feet after t seconds. So it's telling us this distance. So how far it has fallen from its maximum to where it currently is. Now let's imagine the same scenario. We have that same building and that same object is falling, but now we're using this model. So this model tells us the height in feet after t seconds. The model is h of t equals h sub 0, where h sub 0 is the object's initial height, so how high it is before it falls, in feet. So this model tells us this, how high it is off the ground after t seconds. So again, this first one tells us how far it has fallen after t seconds. The second function tells us how its height after t seconds. So similar scenarios, but it tells us two different outputs. Okay, so let's look at example 2 together. This one says, if you drop a water balloon, how long does it take to fall 4 feet? So for this one, since it asks how long does it take for it to fall 4 feet, we would like to use that distance fallen formula, which is d of t equals 16t squared. So here they want us to figure out how long, so we're solving for t, does it take for it to fall 4 feet. So we're going to replace our y value, d of t, with 4, and we're going to solve for t so we can figure out how long, how many seconds it takes. So this one, let's try using that square root method. So let's isolate our squared term. So here we have 1 over 4 equals t squared. And remember, once we've isolated our squared term, we can take the plus or minus square root of both sides. So this gives us t equals plus or minus. So the square root of 1 is 1, and then the square root of 4 is 2. So notice you have to take the square root of the numerator and denominator. Now, one thing to watch out for here is that when you have real life examples and they're asking how long does it take, it wouldn't really make sense to have a negative number of seconds. So although algebraically we have two solutions, in the real world our only answer would be positive 1/2. So it's a half a second. And there you have it. All right, let's try another one. So this says the rooftop of a 5-story building is 50 feet above the ground. So let's draw a picture of this. So here is our 5-story building, and they tell us that the rooftop is 50 feet high. How long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at 24 feet? And then they also want to know how long does it take the water balloon to hit the ground. So here, let's model this first scenario. So it says, how long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at 24 feet? So imagine 1, 2, 3, 4, 5. So here's our 3rd-story window, and this is 24 feet. So here, they're actually asking, how long does it take for the height of the object to be 24 feet? So in this case, we would like to use that second formula. So that second formula was h of t equals h sub 0 minus 16t squared. And remember, h sub 0 should be that initial height, which is 50 feet. So we can substitute that in, and then we have our model. So this will model the height of our object after t seconds. So first, again, they want us to find how long it takes for the height to be 24. So h of t becomes 24, and then we're going to be solving for t. They want to know how long. So let's replace the height with 24. So it equals 50 minus 60t squared. So let's use the square root method again. So we're going to be isolating t squared. So let's start by subtracting 50 from both sides. So that gives us negative 26 equals negative 16t squared. And then we're going to divide both sides by negative 16. Now here, since it is a real life scenario, we can use decimals. So this gives us 1.625 equals t squared, and now we can take the plus or minus square root of each side. So this gives us t equals plus or minus, and then we'll plug this into our calculator to get a decimal approximation. And we get, if we round to the nearest hundredths, we get 1.28. But again, it doesn't make sense to have a negative t value because t represents time that has gone by. So we'll just take the positive and we'll say 1.28 seconds. So that's how long it takes for the height to reach 24, which is the 3rd-story window. But they also want to know how long does it take for the water balloon to hit the ground. So for this one, we can actually go back to that first equation, d of t equals 16t squared, because they want to know how long does it take for the distance fallen to be the total, to be 50. So we can replace d of t with 50 equals 16t squared. And again, let's use that square root method. So let's divide both sides by 16. We get 3.125 equals t squared. And then we're going to take the plus or minus square root of each side, although we know that we're actually only going to use the positive version. And then we can plug this in to get a decimal approximation, and we get t equals 1.77. So it takes 1.77 seconds for the water balloon to drop all the way to the ground. We could have solved the second part of this problem with that first model as well. So we could have done it by replacing h of t with 0, because the height of the object, if it's on the ground, is 0, and we would get the exact same answer that we got with our other model. So it just depends on which one you prefer to use. All right, this last type of problem we're going to do together is a really common type of quadratic modeling problem. It's when you have something that kind of travels in an arch shape. So here, there's multiple parts, so I'll kind of zoom out as we go. So this says Matt and his friends are at a baseball game. A batter hits a home run, and Matt shouts, "Wow, that must have been 110 feet high." Then they tell us the ball was 4 feet off the ground when the batter hit it, and the ball came off the bat traveling vertically at 80 feet per second. So first, we're going to be creating a model that models the ball's height in feet at time t in seconds. So we have this projectile motion model that we can use. So this model is h of t equals negative 16t squared plus v sub 0 t plus h sub 0. So v sub 0 is the projectile's initial velocity, which we're told right here. The ball came off the bat traveling at 80 feet per second. So we can substitute that into our model. So we have negative 16t squared plus 80t. And then it tells us that h sub 0, this last constant, is the projectile's initial height. So it says the ball was 4 feet off the ground when the batter hit it. So that would be the initial height. So this model can help us determine the height of the baseball after t seconds has gone by. So we can plug in any value for t and we can figure out what the height is, or we could try different heights and we could see how long it would take the ball to reach that height. So in part B, it says use the model to determine the maximum height the ball reaches. So what part of the function are we trying to find? So here, again, anytime we see the word maximum always tells us vertex. So remember, the maximum or minimum value always occurs at the vertex of your parabola. So we know we're going to be finding a part of the vertex, but here they want the maximum height. So we can see here that our height is the y value. So since we see height, we want the y value. So we're essentially going to be finding the y value of our vertex. So we know that to find the y value of our vertex, when it's in standard form, we first have to find the x value. So we're going to use that formula, x equals negative b over 2a. And we are going to use this model to first find the x value, and then we'll find the y value. So we have x equals negative 80 divided by 2 times negative 16. And this gives us an x value of 2.5. But again, they want to know what the maximum height is. So now we need to find that y value of the vertex, which is just finding h of 2.5. So we're going to plug it into our model. And then this we can plug into our calculator. So if you plug it in exactly as we've written it, your calculator will always follow order of operations. So it will automatically do your exponent first and then multiply and then add. So I recommend just plugging it in exactly how you see it. And we end up with an answer of 104. So that would be our maximum height, 104 feet. In part C, we're asked to determine how long it took for that ball to reach the maximum height. So again, here we see the word maximum. Anytime we see the words maximum or minimum, it's something to do with the vertex. But this time, since they ask us how long, that's a unit of time, which is our x value. So this is the x value of the vertex. And luckily, we already found that in the previous problem. The x value of the vertex is 2.5. So it took 2.5 seconds for the ball to reach that maximum height. So if you kind of look back at the original problem, when Matt shouts, "Wow, that must have been 110 feet tall," since the maximum height was 104, we can tell that Matt wasn't quite right. He was close, but he overestimated just a little bit, since that maximum height, again, was only 104. All right, the last thing that we're asked to find is how long it takes for the ball to hit the ground. So let's kind of interpret what this means mathematically. If the ball hits the ground, that means that the height, or h of t, must be 0, right? Because the ground has a height of 0. So essentially, we're going to be using our model that we created above, and we're going to replace h of t with 0. So we're essentially going to be finding what the x-intercepts are. That's what happens whenever we set the y value equal to 0. So here's our model again, negative 16t squared plus 80t plus 4. So again, there's lots of different ways we can approach trying to solve this. One thing I noticed right off the bat is that there is a GCF of 4. So I'm actually going to divide both sides of our equation by negative 4, just to make our t squared value positive. So this gives us 0 equals 4t squared minus 20t minus 1. So you don't have to do this step, but when you are able to divide out a common factor, it just makes the numbers a little bit smaller and a little bit easier to work with. So now that I've done that, I'm going to finish solving using the quadratic formula. So let's do, so here we see that A is 4, B is negative 20, and C is negative 1. So you can see it's nicer to use these smaller numbers rather than these larger numbers. So we do x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So x equals positive 20 plus or minus the square root of positive 400. Be careful here, squaring a negative gives you a positive. And then here we have a negative times a negative, which also gives us a positive. So it's plus 16 all over 8. So this gives us 20 plus or minus the square root of 416, all divided by 8. So from here, we can plug this into our calculator to get a decimal approximation. So we will get 2 answers, and we'll look at both. So we're going to do one for 20 plus square root of 416 all over 8, and then one for 20 minus. So let's do the plus first. So when you do this in your calculator, just make sure you're grouping what's in the numerator, because we want to make sure we do the entire numerator and then divide by 8. So for our positive answer, if we round to the nearest hundredths, we get 5.05. And then if for our negative answer, we would get negative 0.05. But again, if you look at the context of the problem, they ask how long does it take for the ball to hit the ground. It would not make sense to have a negative answer, so we're just going to use the positive one. So that means that our final answer is 5.05 seconds. And there you have it. All right, so that is all for today's video. Thank you guys for watching.